Okay. Okay, so we don't get too much out of our time. I would say let's slowly get started. We still have some people joining, but I think they can just catch up as we go. So for the ones who are here, thank you so much for attending the webinar. As some of you know, my name is Katerina. I'm the biotech lead at Sustainly. And today we're gonna have a webinar speaking of how to fuel your biotech growth with impact data. So I'm gonna pass the word on to Frederik, our CEO, and he's gonna walk you through the agenda that we'll be going through today. And then we will have Sumesh and Sankalp from Biosustain join us. And once again, thank you so much for taking the time and speaking a little bit about what LCAs look like within biotech, what are the problems that need to be overcome, and then how can we use the data from the LCAs to fuel our growth. So Frederik, if you want to take it over.
Yeah, thanks, Katerina. So I'll promise that I will keep it short, so most of the time will be for Sumesh and Sankalp, but I do think it's in order to give a quick introduction to Sustainly, who we are and why we founded the company. So I founded Sustainly along with Vladimir's 2.5 years ago, and we did it with the purpose of wanting to contribute to a future in balance. And we're software people, right? So we don't go out and invent new green energy or awesome biotech products. But what we can do is we can support companies with impact data that's fit for purpose, and we can support decision makers in utilizing that impact data. So if you take a look at the status quo that we wanted to challenge, it is that impact data in our minds shouldn't be binary. Traditionally, impact data or LCAs, as it has often has been delivered in these huge PDF reports with a lot of spreadsheet calculations, a lot of data to understand. And while these reports obviously have their place in the world and can be important, they're not always fit for purpose in a company. So we set out to build a platform where the data is of high possible quality, but it's also iterative and scalable. Essentially, we wanted anyone to be able to build their first LCAs in 5 minutes without being able to read lengthy methodologies and comparative studies within other fields. And once we kind of achieved that, we also wanted the data to be accessible and understandable for non-experts. So it's key for us to have a platform where basically anyone, regardless of their level of expertise, can work with the data and utilize it as well. So what we did was we had to build an LCA engine completely from scratch. All the calculations, all the data had to be integrated into scratch. As part of that process, we built the data management, because one of the other issues we could see with the status quo is that the data needs to be better organized. It needs to be organized up against the business data, and it needs to be able to grow and develop along with businesses. So once all of that was in place, and this took quite a while, then we added AI Copilot. So now we're an AI company, right? There's a lot of hype and talk about AI, but what it means here is just it empowers people to work faster with impact data. It means that if you're an expert, it will speed up your process quite a lot. And if you're not expert, you can work with the LCA because we hit all of the complexity under the hood. So experts can open up the hood, take a look, dive really deep into the data in multiple layers. But if you're not an expert, you can actually get started just by understanding your own value chain and your own company. So that's how we cut the cost of getting started quite significantly. So I think I will leave it here. That's my kind of intro, and a little bit, I know I was pitching it a little bit, but there's no such thing as free lunch, right? Now I'm going to hand over the word to first Sumesh, then Sankalp, who's going to share a lot of interesting insights on how you can work with LCAs within biotech.
Yeah,
the word is yours when ready.
Can you hear me well?
Yes, hear you.
Let me share my screen quickly. I guess now you can see the screen as well. And yeah, make it screen, so it's good. Oh, thanks a lot for the introduction, Frederik, and I'll just maybe also take this opportunity. Thanks for the opportunity to share a bit about life cycle assessment. I think many of us, even in the crowd, could be experts in that, but I will try to give more an overview on how we apply life cycle assessment in biotechnology. And here we'll be kind of talking a bit about the institute that we come from, which I'll introduce in a bit.
Sorry to interrupt you. Can you, your screen is not full screen, it's like in presenter mode.
Can you see it better now?
Okay. Exactly, yeah.
Perfect.
Yes, good. So, and then, I'll also talk a bit about the challenges and opportunities. And my idea is, like, by the end of this slide, kind of show you what would be kind of an ideal world for us if we had the best tool available for LCAs in biotech. So I'll kind of end with that point. And after that, my colleague Sankalp will carry on with sharing more about the LCA specifics as well. But just as a short introduction, my name is Sumesh Sukumara. I've been working here at the DTU Center for Biosustainability, which is also a department here called DTU Biosustain in Lyngby. And we've been working on sustainability assessment for nearly 12 years now. And previously it was a lot about economics. Then we slowly merged environmental life cycle assessment. Now we are also looking into social life cycle assessment as a part of our research activities. Briefly also about me, I have a background in chemical engineering. So I've been educated as a chemical engineer from India, moved to US to pursue my education, and then came here in Denmark in 2014 as a postdoctoral researcher, and then got a chance to have a career as well as work with wonderful people here to do sustainability assessments. And somehow Denmark gave us, and DTU is one of the best institutes in the world, both for biotech and in sustainability. So I would say we got this opportunity to join two fields and integrate life cycle assessment with our biotech projects that we work here. So today the idea will be really talking about all the learnings we have so far, but in a nutshell, what really drives us is guiding innovation through quantitative assessments for different technologies. And lately we've been looking into all three dimensions of sustainability. So maybe moving a bit into what aligns us towards sustainability, right? So in biotechnology, some of you in the audience are also from that field. Everything might start with an organism as the main driver of the technology. So the goal is really to make a big change in the world, and that's why we try to make that's the motivation for making things sustainable. But there's a huge gap between what an organism does in a lab to a real solution happening in the world. And if I have to say, there's a lot of in-betweens that has to happen for a solution to come from a lab environment or a research environment to the planet. And this is where a lot of biosolutions are also focusing on. And I think many industries in Denmark are quite geared towards bringing bio and making it like a sustainable solution. So we have to basically grow the organisms in a group, which is called cultures, and then put these cultures into a fermenter. And that's a very typical operation in biotechnology. And then you kind of start foreseeing fermenter working in an industry level, and some technologies also spin out from our institute as a part of it. And then finally you produce wide range of products, and then these products are catered to the population around the world. Now, this is a very simple cartoonish representation of what happens, but what we are doing is transforming basic research in biotechnology, convert it into applied research when things start getting a bit more production oriented, and then we have to develop the whole technology package around that fermentation or the microorganism, and eventually make a system working at a relevant environment. We call it prototype or systems development. So this is a typical workflow that many other technologies also go through. But in biotechnology, one of the things that we have learned is sometimes things may take time, a lot of time for this to happen, and that is why we try to integrate sustainability assessments right from the very early stages of the research to guide the whole R&D workflow. And it is not a one-time thing that we try to do. We try to do it at every stage of development. So both we refine our models of sustainability assessment, as well as the researchers gains insight from that model. And if I transform the same, blocks into TRLs, I think this is what technology readiness levels were explaining to. So our goal is really to go from a technology readiness level 1 to 9, where 1 is really about showing a basic principle working, but 9 is really a system deployed, working at a good commercial scale and even producing products that could be shipped to different parts of the world. Now, one of the terminologies that's very common in biotechnology is valley of death, and one of the reasons being that we have a lot of good ideas in biotechnology, and also many of the ideas has a very good logical alignment with sustainability. But often when the technology scales up and you start repeated things, and when it reaches around TRL level 3, where you start doing the proof of concept, you start realizing that maybe the performance is not good enough for us to really make it to market. And that's where a lot of ventures taper down. And some of the successful ones are funded and keep funding, and that ends up being in different sectors, and often going into private sector where things are being produced and sold around. So our idea is really to bring a lot of information, and in this case, I'm more talking about the impacts that we can quantify at an early stage, so we can really see what will be the end for a microorganism or a microorganism-based technology going into the market. And here we are looking into all 3 dimensions of sustainability. Now, in our research center, I will be also a bit modest in saying that I've worked with all these TRLs. I mean, some of the TRLs we are still learning at high level, but really day-to-day activities happen from technology readiness level 1 to technology readiness level 5, where a system is deployed at certain conditions which reflect industrial operation, and it's not typically in a meter cube scale. It's still in a 100 or 200 liter scale of production. Now, this term sustainability is kind of encompassing 3 aspects: economics, which is relevant for a business to go out to the market, but all these economic activities has to be done for the well-being of the society. And while we do that, we should also make sure that we are not transgressing the limits that the environment has for it to recover back. And I think I'll get to that in a bit later as well. And all our activities at the Center for Biosustainability are also geared towards supporting research teams here to drive through sustainability assessment biosolutions, and we would also like to deploy these methods in the long run for them, so that they can make their own sustainability assessment, and maybe also resonating with what Frederik was saying earlier, being more faster and being more accessible. Because often, if you are a person who's been working with these models, you'll know that many of the models are meant for specialists to work with, and it's not really anyone can jump into these models in a very short time. And that's something what we also think is a good development that's happening around the community in the life cycle assessment, where biotech can also gain a lot from. Today's talk, I'll focus again on the applied research part of it and not really go into deployment, while we have some projects working with different startups as well as Novonesis and other bigger companies doing sustainability assessment. But really, the idea is to guide research at early stages, because that is where the sustainability assessments are somewhat slower, because the availability of data is less. And this data, in life cycle assessment terms, we call it inventories. So we need inventories to make any successful or any good impact assessment, right? So often when a project starts, I think it could be a project based on enzymes or food, or it could be some other developments happening based on synthetic biology. We have to latch on to the research group to give us data, and then we have to scale that lab data to a higher scale that represents ideally something like what our industry would be doing, and then make impact assessment out of it. And this part is somewhat slow in our experience, and this is where I think many of the new developments could be brought in, and we could make the sustainability assessments a bit faster. And I'll come back to it why. Because when we talk about sustainability assessment, the simplistic view was 3 pillars of society, but actually it's much more than that. It is actually many tools that has to work together, and I've kind of, there's some tools that will be gathering intelligence about the market for a new product. There'll be supply chain that one needs to work on. We also need to see if consumers are willing to accept. There's a social aspects to it, because everything is done for good of the society. But really, from a technology perspective, when a technology matures, what we really need is to get some simulations working, because at that point the technology is not representative of what will happen in the market, and then develop economic assessment, and then finally fuel the environmental life cycle assessment. And we'll be focusing more on this aspect here, how that workflow is generated. And eventually this iterative process happens from TRL 2 to 5, and that's when we start generating results and tools that could be used for automation. So now maybe it was a bit background of why we are doing this research, for us to kind of align. But the whole idea is also to kind of align with the policies out there, right? So LCAs also has been used for decades now in policy aspects, and recently it has been also used up in shaping up certain policies, and more towards biotech as well. So there's a lot of history of how LCA evolved, and if you look at the very first formal LCAs, which happened in 1969 to now, there's a huge demand for these kind of analysis, because these analyses have been standardized in the past decades, and people have been, both companies have been using it towards producing APDs. European Union uses that to make a lot of policies, and I think especially for us being in EU, it's quite relevant, and much more activities are happening, and one of the reasons being that this gives us a very equal ground of comparing technologies, while as a practitioner we may also know the drawbacks of how one could change details to make it still fit the standards, but at the same time create some results. But that's maybe for another time. But really LCAs have been used in policy making for a long time. If you kind of see policies, there are kind of binding and non-binding policies out there. And really, the 3 things that one needs to keep in mind is the decision, regulation, and directives, which are more binding. And if I kind of take a summary of how these policies have been also evolved, they have been quite a lot accommodative of LCA-based assessment. In fact, many of the policies, especially when it comes to, and kind of you can see on the right side, the various type of products and number of documents that has been generated in the European Union to guide policies. And a lot of this decisions has been done towards household goods. Research programs have also been shaping up based on these assessments, and chemicals and plastics, which is also one of the fields that we work with, but pretty much every other field is getting affected by having LCAs out there, right? And that is something we in biotech also feel is good, that we very early stage itself start adopting life cycle assessment mindset, systems analysis mindset, so that we can also get the impacts maybe more matured as the technology matures. Now, that was the policy part. But if you look into biotech, it comes with a lot of promises, and I kind of call it attributes because it could be a good or bad aspects of biotech as well. So if we look into the good aspects, biotechnology offers us renewability. It offers us potential to be carbon neutral. It can gain from diverse feedstocks, and we can create a lot of jobs that are not centralized but rather decentralized from one location. And lately, we have also gained a lot of know-how on how to improve the yields using some manipulation of the organisms. Right? So these are all good things. But also, to be very fair, we also have some issues with the biotech, and that is why the systems analysis and environmental life cycle assessment is quite important in biotech, because to grow any resource, if we are doing a dedicated industry based on that, land will be used because many of these bio-based products need land. Many of the bio-based feedstocks are seasonal, and some of them even compete with food. There are a lot of indirect impact, which might not be obvious right away, but if you have done an LCA, you'll start seeing a lot of eutrophication, for example, that happens due to growing of this biomass. And economically also, because if you just look at the energy density of fossil versus energy density of the same volume of biomass, it is much less, and that leads to often higher cost and also scalability limitations. So when we start this assessment, we don't go into thinking that bio is always good. We think that bio is a very clear enabler, but it is not the sole solutions, and we need to still design biotech using the environmental life cycle assessment information to really make a good change towards sustainability. And now a few slides, I'll share a bit about specifics of how the inventories are being generated in our context in DTU Biosustain, and how we try to link the research activities in the lab to the planetary impacts that eventually all these tools are meant to be doing. Right. So first things first, again, keeping the line of things have to develop, but this time with a bit more resolution. So we have microorganism that goes into fermentation and fermenters, which I mentioned earlier, but this fermentation is part of a bigger product system, which is called, we call it biomanufacturing, where you take a feedstock and you produce a product. And this product and feedstock are part of a supply chain. And if you kind of include the end of the life treatment, so you can call it a complete life cycle. And this life cycle has to exist with other life cycles and other supply chains out there to really cater the planetary demands, right? And there's also social aspects linked to this. So, like we have a method of doing things or systematically organizing our system here. And parallelly, in biotech research, there's also a cycle that happens. We call it design, build, test, learn, DBTL cycle, which also has some methods in which data is generated and things are being designed. And here, when I mention it's mostly design of the host organisms. So our first challenge was how can we link the sustainability assessment mindset, where we try to zoom out of things to really planetary level, and link the data in using the DBTL cycles. So here, really, it's all talking about taking a microbial level information to a industry level. And here, one of our PhD students was the first one who kind of started linking these aspects and tried to, in the inside part of it, you can see the DBTL cycle, but outside you can see what are the things we did in each stage of it. So, for example, we had to initially itself define a functional unit that was consistent with both economic, environmental, and social impact, and then generate inventories, and then later on create life cycle assessment models. Back then, we used to use OpenLCA and Singapore, but now we are also trying sustainably. And then finally, we get some outputs that goes back to the researcher again. But how does that happen? Because in a microorganism level, the details are completely different. I mean, we are not talking about inventories yet here. We are talking about yields and some parameters that are very fundamental. And often, there are two ways that happens. One, someone has generated experimental data that is good, because then we'll have some good amount of mass balance to scale up our data. But often cases, we are also asked to to kind of work in the dark. And then we have to use some computational models to really generate a lot of hypothetical scenarios. And eventually these scenarios can be just, let's say in this case was about producing a polymer called cellulose bacterially, but sometimes it can also be about, creating information about other projects. And eventually we end up publishing it and using it for educational purposes. Now, if we go to the next stage, which is really, now we have a good understanding of how the process works. Now we need to generate the whole supply chain kind of information out of it. And for that, we need to have a good information on the production system to begin with. Here again, we'll have two cases. One, someone has done experiment on the whole part of it, which is often unlikely because in early stages, you are barely running your fermentation successfully. But often we'll need to use some state-of-the-art estimations to generate, and this is where we are now getting into the inventories that can fuel life cycle assessment, to generate the data, what will be the input needed for a particular product to work. For example, how much glucose is needed to produce a polymer that goes into a bottle. And these inventories, eventually, we do hypothetical studies to see, okay, there might be, let's say we are showing case of a beetroot-based product, beetroot food, that base product that is used as a food colorant, but now we have an organism, which is Yarovia, that can produce the same colorant at different levels, and we can consistently see how the production rate and titers will impact the economics and environmental impact. So that's the aspect that happens in this stage. And then we take a step forward, and now we start linking things into life cycle perspective. And here, most of the work of us happens in relative life cycle assessment, because environmental life cycle assessment by itself is to compare products. But we also have workflows to link it with absolute sustainability assessment, where you take an LCA, but you start foreseeing what will happen, and you have some methods to be applied there based on some allocation principles of what will happen if you start deploying it on a global level. And these are, again, some hypothetical scenarios, but we try to see that for certain projects, let's say, for example, food, because that's something that one could imagine that if you have a good solution coming out of our research institute, how will that affect the planet if everyone starts adopting that kind of a solution? So this is how we kind of scale from organism level to kind of a planetary level. And the final part is really to go back and feed back this information that we got. And this is, I'm just talking about the one run, right? Imagine if these runs are happening in every blocks of the TRL level development. We are talking about a large amount of time. And in the past 5 years, we have kind of did some mathematics for this seminar. Roughly, to do an LCA one time, it takes us a month to 3 months, depending on the maturity and availability of data. And to do it repeatedly, we are talking about months of effort, right? And that is something that we really want to reduce. And that is why we are going towards generating inventories faster. And we are very supportive of any development that is also absorbing these inventories faster to make sustainability assessments. So like you have a goal and scope, inventory and interpretation aspects in LCA. Similarly, inventory generation also is quite an integral aspect of techno-economic assessment that we do. We call it TEA. And here, the idea is really to generate a lot of high throughput data on raw materials, products, co-products, waste materials, and also utilities and consumables, so that it can be linked in directly, or maybe rather seamlessly, to the LCA frameworks that we do. And these are some examples, but depending on the product to product, it could be, sometimes we may also need market information that may also be necessary for doing some allocations later on for the systematic assessments. I've just kind of showing some snapshot of how we do it in-house. So that we have like an in-house dashboard where one can actually go in, change the different technical aspects, and start calculating inventories and the economic impacts of it. But what we don't have, and that's something that Sankalp is working on, is automating these workflows also to do environmental life cycle assessment. And I think that's something is one of our active research areas, like we are doing for economic assessment. Why don't we start thinking of environmental impact assessment, because that will really enable scientists, and again picking on the thread that Frederik was giving, to do some quick assessments, first beginning with inventory generation, then doing economics, then environmental assessment, and hopefully also social, to really bridge the gap between or also reduce the time that takes into maturing a technology. And and this video goes for long, but really the idea is to make it more seamless. And since past months, we've been also exploring a lot of tools, and our main go-to tools as of now is there are a few, but OpenLCA, Sustainly, Brightway, these are the ones that we are exploring, and I think Sankalp will share more about it. But there are also other tools that needs to be integrated with it, right? So if I'm just looking into one aspect of sustainability, it's maybe not really doing justice, because sustainability is about a lot of indicators from a lot of different backgrounds. And somehow economic part is somewhat simpler, I would say, because people can very easily imagine money, and because we kind of do day-to-day activities in monetary levels. But we have many indicators when it comes to life cycle assessment. Now there's also planetary boundaries that we are talking about, and numerous social indicators that we are working with. So still, maybe the bigger challenge or research question is that, do we have tools out there that biotech can learn, but also for the other communities that can really answer this question mark of, can things be sustainable? Because as engineer, I would like to plot things in the 3 dimensions, which I think is the bigger drawbacks of any tool out there, while there are good mindsets of going forward towards it. And for us, really, it's about making someone who does the experiment can travel the journey and make a planetary impact assessment faster as well. And I showed you one example of integrating design, build, learn, test cycle in biotech with different assessments that we did. But that was one silo project, and we learned from it and adapting this methodology to maybe 10 projects now. And that's something that we have learned over the time to maybe automate a few workflows. But really, it is about giving the power to people who do experimental work, who are not people from the LCA background, but still have some good knowledge, because you can't blindly go and do an LCA as well. You need to still know what is the relevance of a parameter. There needs to be educational part here as well. But once they are educated, they should be able to maneuver tools. And some of the tools are maybe notoriously difficult for people to maneuver from a biotech background. That was our learning in the past years. So if I have to kind of end in some silver linings, I think we are really excited that simple tools are emerging that can export data in various formats that could be integrated, quick visualizations, researchers from different backgrounds can maneuver. That is one aspect of it, but I think I would even stretch it a bit also to raise some questions. Are these tools also detailed oriented, and can this be integrated with other assessment methods that are emerging, like planetary impact assessment? Can we do multi-objective optimization, and can we integrate different sustainability performance indicators here, right? And there are many other advanced analysis that one could think of being in this domain. And the third aspect, like we have 3 dimensions of sustainability, I think these 3 dimensions to me for a workflow will be really good if we can also automate these workflows. So something that can be simple to use, but also generate a lot of detailed result. But we can also use these workflows to maybe latch on to some high throughput assessment that's happening, because we are going into a stage where data is often read quite fast. Even in biotech now, here we have a lot of robots that are really analyzing the data and even customize the output to the needs of the stakeholders. And maybe a holy grail would be to make some of these tools even open source, so that the whole community can learn. And I think that is what drives us to do this kind of research. And maybe concluding here is, like, there are a lot of people who are working on it, but really the idea is to make it faster and to be to really generate a lot more information in a shorter time for the whole workflow that I showed. Last but not the least, I would now maybe wrap up. Maybe I'm also ending a bit over time, I would say, but still give acknowledgement to people who have been funding and the projects who have been funding, and a wonderful center that has given us a test ground for these assessments to be done. But I'll be happy to take questions later on, as I understand. But please save your thoughts, and I'll be happy to comment and share more learnings as we go. Yeah, thanks.
Thank you so much, Sumesh. That was a great talk. We're going to now move on with Sankalp. And I just wanted to tell the attendees that you're more than welcome to drop questions as the webinar is going. And then in the end, we will take as many as we can and we will go over them together. So feel free to ask away in the meantime.
So, Sumesh, if I may ask you to share the screen,
Yes,
it is
yes.
not allowing me to share
I
the
can
screen.
do that right away.
I think you should be able now as well, Sankalp. I just needed to make you a presenter, apparently.
No, actually, it's my browser that does not have the permission. I would have to restart the meeting otherwise.
No, but let me just do it in the interest of time. So I think you can hear Sankalp. See the screen. Get full screen and make sure that it appears well. No, presenter mode, right?
Yes, it's a presenter mode.
And now, good.
So, thank you, Sumesh, for this great talk. And I will continue with few of the things how we are doing with the LCA and what are the first impression of Sustainly is. A bit about me. I am doing LCA for last 5-6 years, and I work mostly on doing different LCAs for the product system that we do here at the DTU Biosustain. And my research focus is mostly bio-based products and food system, and also looking into the future with prospective LCA. In interest of time, I'll move a bit forward. Here is some workflow from one of our colleagues. They did a paper on automating relative to environment and absolute sustainability. And what I would like to focus on is this box, which I mentioned, time intensive. How, as Sumesh mentioned, we have low TRLs and we get the data. And this generally comes up from different process simulation models. And then the challenge for the LCA person becomes is how to integrate this process simulation data inventories that are being generated to a workflow for in the LCA software. And in this paper, they very well put forward a workflow that could be used to automate this. And here they use OpenLCA, but the challenges remains there that you have the inventories that are coming from process simulation models, and then you have to integrate somehow with the LCA software. And this can be a bit challenging, specifically because we are two different domains, process simulation and then LCA. The way people model their process simulation model might be different from what is needed for an LCA model to look like. The vocabulary they are using could be different from what you generally see in an LCA study and databases. And one example is that, for instance, you have calcium chloride. The process simulation inventory just mentioned that, but then you need to find which of these market processes in the background database could be representative for the input flow that is there in the process simulation model. And that is something you need a lot of time on. You have to spend a time on identifying everything, which flow goes where. There is a need for faster LCA model setup. Otherwise, most of the time goes into the mapping of process simulation model to LCA models. There is another important aspect that there is need to be reusability of the model. We do LCA and we create these models for product system, but they just sit there. Later on, they might not be used. And every time you have to do an LCA, somebody starts a model again, creating a model again, which could be, I would say, we are redoing steps which we have done in the past. And there has to be a way where we can kind of able to keep our models in a way that we have data and models separate and allow it to be shared and collaborated with others. One of the other aspect with the LCA specifically is the reproducibility of LCA. Many people do LCA with their different assumptions, different system boundaries, different functional unit, and it's often so far up until the open source tool like Brightway and Activity Browser came along. It was mostly these traditional softwares that people were using, and sharing of the LCA models was a bottleneck. And also from version control from one software to another, different database to another, that could hinder the process of reproducibility, traceability, and validating the LCA models to check the accuracy of them. And then there are tools which they able to do this, but then they lack advanced functionality that is kind of needed from understanding what is happening in your LCA system, LCA model, to make better decisions. So far, I have spent some time in testing sustainably, and here I would like to give my few first impressions. I would say that I have not modeled a complete product system, and what I'm showing here is just a very basic case with dummy data. But this is what most of our product systems at least look like when we get inventories from the TEA or any process simulation model. So you have media, fermentation, extraction, and concentration. What I really like here is that I was able to create these 4 stages with the help of AI. That is part of Sustainly. So I just gave it a prompt that create 4 stages: media, fermentation, extraction, and concentration. And then I gave it all the names of each input node that should be in that particular stages. And it created those empty nodes for me. However, the linking with the background data you need to check, just like any other AI system, that you have to do an iterative process to make sure that it works correctly and it's do the correct connections for you. But this particular aspect can be a bit of time consuming for somebody starting for the first time with LCA. And there's a way that you can do it faster, which I really like so far, that it enables for people who have some education in LCA and are starting with a new software tool, can quickly create some of the basic models that they want to start with. And then we have a very nice help screen. Most of the tools you generally have to go into your documentation. So here I was a bit confused in the beginning, what are components and what are suppliers in Sustainly. Again, with the help of their AI tool, I just asked it, and it kind of helped me to understand what is a component and what is a supplier actually mean in this software. And then it can help you to do what I was saying, that we are doing LCA, creating models, but they are just lying in the back and we are not using them again. So with the component feature, you are able to create some LCA models then you can integrate in your product system in the future. And this is what I tested for this in my system. So I created 2 components, extraction and fermentation, and these are different models. So they are not part of the product system I modeled before. And then I added the fermentation component directly into the fermentation stage. And this would mean that if I would have created a product system or a stage before, and I want to reuse it again in a new project, I can use it just by adding it through components. And I think that is kind of helpful when you have a big data sets and multiple projects. You want to reuse your LCA model, you don't want to start from scratch. And this integration feature was really nice to see. Few of the things that I also liked, and I think these would be helpful for the beginners, is to see which stage contribute to what percentage in your environmental impact. The recommendation, I think for the beginners and industry, this would be very helpful to understand what kind of reduction that you need to do and where. And here I clicked one of the process card of the recommendation to see what does it say. And they say that invest in more efficient steam generation technologies. And this is one of the input flow from background database EcoInvent market for steam in chemical industry, which is used in fermentation and other processes. and it is a hotspot process for your study, then it could give you an idea that, okay, I have to invest and look for a bit better data, at least for this process, and maybe find some sensitivity analysis for stream to get or reduce the impacts. Then again, with different aspect, what I would really like is that there are some collaborative features. So for me, it is important that the person who is working with me is coming from the TEA or process simulation background, and they know their system very well compared to me, who is just doing an LCA of their work. They understand what is happening with the product system. So once you have created your LCA model, they can comment, they can verify the processes is actually according to the one they see in the lab or would like to see in the scale-up systems, and they can change the data itself with if there is some error or something needs to be changed. This aspect, I think, is important when you're working in teams, specifically because uh, the sharing of LCA models is always challenging if you are not working with something that allow collaboration from one team member to another. There is always version control. There is always different databases, different software versions, and that kind of create a bottleneck for collaborative effort in doing LCA. And I think it is much important to have a collaborative effort in LCA, specifically when you are working in multidisciplinary teams and there are different as experts who are collaborating and giving you inputs for different product stages. The other thing that is really fascinating is that ability to see different scenarios. Here I created 4 scenarios: scenario 1, base case, scenario 2, and then the connector one, which is, I think I took the component part here, but ability to see what processes are there, what are their values are, input values are, and if you want to change something, you can edit it here. So different in specifically in TEA, we have different simulation runs, different output of sensitivities, and then you can create all these scenarios at the same place and run them, change them, the values, and see the results right away. In conclusion, I would say it is a very good step forward for teams and new users to getting started with LCA. As I said, the bottleneck is going from the process simulation model to the LCA, and it maps input flow from background database and set up LCA model in the beginning with the help of AI, which is a bit faster than actually creating a mapping system. But it needs to be checked, it needs to be corrected. Components allow reuse of previously created LCA models across new product system. And AI integration is making onboarding easier, but just like any other AI tool, you have to check what it's doing and don't trust it blindly. There are many other features that I still need to test. However, from the first impression, I really like the tool's collaborative effort. And one important thing for me who have been using this traditional software, that it's a different paradigm from traditional LCL software in terms of modeling with the stages, nodes, and specifically looking at the how different stages can give you results. That is something I think from anyone who is joining it from a different or a experienced LCA background will take some time to get used to. Though it's very easy to understand, but it's a different modeling way, and it takes a bit of time to learn. But these are a few of the first impressions that I have of the tool, and I really welcome these advances that is happening in the field. And that's all from my side for today. Thank you.
Thank you so much, Sankalp. That was a great intro to what our software can do. But yeah, so now Frederik is going to just wrap it all up, and then we can take a couple of questions that the attendees have posted so far.
Thank you. And I will be, once again, I will be quick. But I do wanted to just say if you listen to these great talks by Sankalp and Sumesh, and you think this is interesting, I'm a startup, how do I get started? Or I have 5 colleagues in an LCA team, and we're juggling, spreadsheets around every day. I really want to say that the key message here that I also started off with is our goal is to demystify this. So just do it, just get started. I'm sharing Sustainly now, right? And I'm sharing an LCA for an organic t-shirt that I did in 30 minutes yesterday. And I very intentionally did not choose a biotech product to show how little I know about biotech in practice. But what I want to show here is just like, if you understand the basics of how a t-shirt is produced, you can perform an LCA in half an hour. You can see the impact report. You can dive into the different hotspots here. You can go in depth with the results, compare the scenarios. What happens if we switch to recycled cotton? You can build components for the different elements that are reused across your value chain. So if I'm going to leave you with like one takeaway from a very practical perspective, it's not dangerous. Just start, build the first model in half an hour, find the hotspots, improve the data a little bit, and very soon you'll actually have data that you can use when you talk to your customers or investors and so forth. And if you ever need that really, really high quality, in-depth research level data, well, it's fantastic. You just call, Sankalp and Sumesh, and they can jump right into Sustainly and help you further qualify that data. So really, just get started, test it out. And I think now that's the end of me talking, and now you can have a chance to ask any kind of questions if you have them. But thanks again to Sankalp Sumesh for some really interesting talks here.
I think I'll just quickly jump in and read one of the questions that we have from our attendees. So it is asking, does a model apply? In model, I would imagine it's tool apply to chemistry-based tech as well. Or would you say is a good point to do one of the first LCAs?
Yeah. So thanks for the question. I think the model applies for any kind of tech, right? So I mean, that's maybe how we really define the inputs and how we kind of get the performance indicators in there. Second part of the question is actually quite interesting, because this is something that we have also learned over time. In the beginning, our goal was really to start from TRL 1 to 5, but then later on in my slides, you might have seen I made it to TRL 2 to 5. Why? Because you need still some solid information to start these modelings, right? I mean, in our case, whenever you get something out of a lab that is repeatable, that is where we start. And we just don't start with an idea, because with an idea, we can go in all directions, right? So when we have some solid data that is being documented, it has been repeatedly logged, we start then. And then we also ask a question to them. Let's assume that you are going to TRL 9. What will be your best case scenario, and what is your scientific link between now to then? So they have to theoretically come up with saying that, okay, I know that this organism can have a theoretical yield of this much, so we are aiming for that, and we'll be cutting down some pathways to achieve that, and so on and so forth. And then we do LCAs in that bandwidth, so to say. So we don't do one LCA for lab only, because doing LCA on a lab parameter is kind of obvious that the results won't be great, because it is still in a very early stages of development. We kind of push them to give us the best case scenario. And if the best case scenario is not good enough, then I think one may even question the idea, if the idea is good enough either. And often the best case scenario looks promising, but there has been also cases where that's not good. But I think we should start, coming back to the question, we should start at TRL 2, where things are more repeatable and people have a good understanding of what are the results that you can get out of a technology. And then onwards, we could do it maybe more repeatedly, because some things get eliminated, some things get added. But I think as the process or technology progresses, the idea is often that it gets a bit lean in terms of resource consumption. That's how we have observed.
I'd love to actually ask a follow-up to you, Sumesh. So one of the characterizing factors of biotech when looking at it from an LCA perspective is how data scarce the field is. So how do you tackle those like very concrete kind of modeling challenges where you have some kind of chemical input or feedstock where maybe the background databases aren't really good enough? How do you handle that kind of uncertainty as it is today?
And Igor, I think this is something that I would say pretty much every other project also has to kind of adapt to, I would say. I mean, coming to your question, Frederik, I think it's a thing that we observe in every project, but I must also say that there is not one good solution to it. Over time, we have kind of started seeing things maybe more in terms of the production itself. For example, let's say if I need to get a data of some amino acids, which is often an essential thing going into biotech-based production, and if you look into the database, let's say EcoInvent, you will not have maybe a lot of amino acids there to pick from. So we had to, in the beginning, we had to even invest in a 3-month campaign to even generate a gate-to-gate inventory for amino acid and link it to where the EcoInvent ends, and that's a longer process. But also then we parallelly were also doing analysis of taking that versus taking a proxy otherwise. And often in different cases, some cases, in this case, the proxies were quite different to what we modeled in detailed manner. So there was a value in creating that kind of additional data to really link it with the missing data in the database. But in some cases also, we have found that sometimes the advancement of spending 3 months is marginal. So in those cases, I think maybe proxies work fine. But it's hard to make a guideline saying that you can take proxies or you should do it. Ideally, you should always be thorough in selecting. At least you should look into the chemical similarity of the proxy versus the thing that is. I think that always prevails. I think logic always prevails. And in those cases, we have seen lesser variations, but it's a case-to-case basis we have observed. So we also take proxies, but then there needs to be a logic. Why are you taking that proxies? And that's how somehow we weed out. But there's no one answer to this question, and it's a case-by-case what we maneuver. Yeah.
Thanks.
Thank you.
Any more questions?
Oh. Thank you so much for the answer, Sumesh. And then maybe on my side, I also have a question, because as kind of the biotech lead within Sustainly, and also I'm very involved in the entrepreneurship ecosystem here in Copenhagen. And one of the things that I think is very important to touch upon is maybe in your experiences, Sumesh, mostly, when do you see that it's relevant, and how do you see that it's relevant for innovation and startups to start doing these LCAs? And at least from what I've seen and from what I've been talking to within this field, is that it is quite advantageous for the startups to start doing LCAs, preliminary LCAs, very early on, and then adapting them as they go, because this can give them a very good direction, and it could help a lot in decision making. But maybe you could speak a little bit on this.
I think nowadays, mainly it comes down to, a business plan level, right? So nowadays, even these environmental impact assessments are being, you need to document that even when you have to raise funds and so on. And that wasn't the case when I started my career. It was all about economic impacts only. So there is some push to innovators also to generate this. And also, I would say, nowadays we also see people with that mindset who are really there to make the change, and I think that's a very welcoming sign. How early? I think it depends from project to project, but many of the time, if you are a startup, you have already you had a solid idea based on which it has gone through a due diligence process where someone has tested your ambition or idea. And I think most of the startups that we work with it happened rather fast. They had most of the data there to do some preliminary LCA. One of the challenges is that being in universities, we also have to find research angle to it. So if there is a research part to it, I think that's when we kind of have to really say there's a research aspect, then there's application of LCA aspect, because we don't just do project just to do another LCA, because that's less rewarding for us. And those cases, I think people should use our tools out there to get the LCA done quick and fast. But also, I think where things are a bit missing, where you need to fill these kind of data gaps, or some new product is there which hasn't been seen and the ecotoxicity impacts are not there. In those cases, I think they need to do maybe a bit more background work and even getting those information, and then start doing an LCA, because maybe you're creating a new product and your claim is that you're replacing a toxic product out there. But if you don't have the right characterization factor for your product, how will you even compare that versus yours, right? So I think in those kind of cases, I would maybe urge back to the innovators to get and work on some of these data first, and then come to LCA. And I think that's at least what we have observed. But if you have a decent understanding of mass and energy flows of your system, I think doing a preliminary LCA will only take you forward. I don't think it'll take you back, because it'll give you more information on what the hotspots are and what could be analyzed. And this is where I really see tools like Sustainly, and also, just to be also very objective, Brightway, and these are right developments, I feel, because they are enabling people to do things maybe faster.
Yeah, thank you so much, Sumesh. And I think, that's exactly where we want to have impact, is that we want to help those early stage startups and those people who do not have the expertise or the time to conduct an LCA in the old ways, to have access to our tool and do it easily. I would just like to thank once again Sumesh and Sankalp for joining us. It was great to have two experienced voices in the field joining us, and being able to speak not only of what LCAs within biotech look like, but also what our tool looks like when being used in that space. So that was incredibly cool. And I'm just gonna wrap up. We're 3 minutes out of time already, and I'm gonna leave a quick poll for our audience to reply if they want to. But otherwise, thank you so much for joining us. Thank you, Frederik, as well, for the words. And yeah, we will see you guys another time.
Thank you. Bye-bye.